today's video we're going to be looking at how we write and name the formulas for our molecular compounds. Molecular compounds again are those that we have the sharing or covalent bonds. So there's no ionic. So the rules are a little bit different. When we have a binary molecular compound, that means that we have two nonmetal elements. It could be any of the nonmetals. Again, you have to look at your periodic table and you're looking at the elements on the right-hand side of that stair step where your metalloids are at. There's no ions or charges because that is an ionic bonding only. And the elements can combine in multiple ways, and so we specifically have the rules for covalent bonding because of that. For example, we could have CO and we could have CO2. They're both made up of carbon and oxygen, but just different amounts. So we can't call that, in our old rules in ionic bonding, we would have said carbon, and then we would have changed the ending of the second one to oxide, and they both would have had the exact same name. And a scientist reading through a set of directions and it says add carbon oxide would have no idea which one to add. And so the rules when you're naming a molecular compound because of covalent bonding are going to be different. Let's look at how we name these and then we will do some examples. So first of all, you want to make sure that your two elements are both nonmetals. So eventually you're going to have some worksheets that have ionic mixed with covalent, and you're going to want to make sure that first of all you do have a covalent bond, that they are molecules, or you'll have to follow the other set of directions. We're going to be using prefixes to represent a number for every element, and there will be a chart that you'll want to refer to that. And if there's only one of the first element, we don't include the prefix for one is mono. So we don't say that we have, we don't add the prefix to the first word if we only have one of them, but the second word always gets a prefix, whether it's one or whatever. The ending of our second element is still going to change to IDE. So that is a common rule with ionic versus the molecular compounds. Okay, this is the chart I was referring to. So these are prefixes. So this prefix will go in front of whatever the element name will come after it. So these prefixes are ones that many of you might already have some of them committed to memory just because of things you've done in other classes, like a pentagon has 5 sides or an octagon has 8. So many of these you may already know, you may know some of them already. So let's do a practice. We had CO, so we obviously are not going to call it carbon oxide anymore. So what we're going to do is we need to know how many of each atom we have. We have 1 carbon and 1 oxygen in the formula, and so to follow our rules we're going to be using the prefixes and putting those in front of the name. We have 1 of carbon, and our rule says that if there's 1 of the first element we don't include mono, so it's just carbon. The second element only has one oxygen. The second element always gets a prefix regardless, so it will be monoxide. So we still have the IDE ending change. It is mono, M-O-N-O, and then oxide, and grammatically they just combine that together. So it's monoxide, all one word there. Now CO2. Again, we're not calling it carbon oxide since it's molecular, only now we have 1 of our carbon still, but we have 2 of our oxygen molecules. So because of that 2, that is going to change the prefix that we use. Instead of saying carbon monoxide for 1 oxygen, it's now going to be, you guessed it, carbon dioxide. So because of the prefixes, we now have a way to tell these 2 elements apart, even though they use the exact same elements. They have different amounts of them, and so our name reflects that. If we look at Cl2O8, again, molecular because chlorine and oxygen are both nonmetals, and if you look at how many of each you have, the 2 behind chlorine says we have 2 of those, and we have 8 oxygens, and so we need to look at our chart, and what is the prefix for 2? What is the prefix for 8? And those prefixes go in front of the words. So we have dichlorine. Again, it's all one word because it's a prefix, so dichlorine. 8 is octa, so it's dichlorine octa oxide. So we're still changing the ending of our second name always to the IDE. SF6, this is our last one before we write formulas. SF6, we have sulfur and we have fluorine. We have 1 sulfur and 6 fluorines. Now again, our rule says that if you have one of your first element, you don't write the prefix. So that was just going to be sulfur to start us off. And then we need to know that the prefix for 6 is hexa. So we have sulfur, hexa, fluoride. We have to change that IDE ending for the ending. So there's our, there's our prefix. And then we have the, the root of our word, and then the IDE ending. Now, if we look at how we write the formulas, okay, so now you're given the name, you have to write out the symbols and the numbers. So we're going to be kind of working backwards. You're going to be given the name, so you'll have the prefix there. You'll be able to take the prefix and figure out what subscript number you need for that element. If it's dicarbon, then you know you need a C2 because there's 2 carbons. So you can use the prefixes to tell you how many of that element you need. And then we just want to make sure that we write the correct symbols and that we put the subscripts, again, they go behind the element. The prefix comes out in front of the name, but that number we stick behind it when we do the formula. If we take a look at dinitrogen monoxide, for this one you have di, so that means 2 of our nitrogens. We have mono, so that's 1 of our oxygens. And now if we take those prefixes and we kind of rewrite it now as nitrogen is an N, O is oxygen, we have 2 nitrogens, so that has to be a 2, 1 oxygen, and we don't write 1s, right? 1s are understood. So N2O would be our final answer there. Silicon monocarbide. Silicon monocarbide. Notice there's no prefix. So no prefix is a great indicator that we only have 1 of that substance. And this, we have the monocarbide, and so that tells us we only have 1 of the carbon. Now you need to know what the symbols are for silicone. So silicone's an Si, and carbon is a C, and since there's 1 of each, we don't write 1s that are understood, and so this one's good with just Si, and then capital C for carbon. 2 more. Carbon tetrabromide. We have 1 carbon, again we know that because there's no prefix out in front of it. Tetra though means 4, so we have the element bromine from bromide. So we have 1 carbon and 4 bromine, and now those numbers go after the symbol. So we have CBr4. Last one, diphosphorus trioxide. Again, take a look at the prefixes here. Both of them have a prefix. How many of each one do you have? What elements do you have? Hopefully you would have said 2 of the phosphorus and 3 oxygens. And now that you have 2 of phosphorus, 3 oxygens, what is that going to look like in a formula? Go ahead and write it out. And hopefully you said P2O3.